Okay, we're back again. We're still working on transformations of trigonometric functions. And this time, we look here, we have a graph. And just looking at that graph, we're going to give a function that represents that graph. We're actually going to give a couple. And if you think about it, there's actually going to be infinitely many functions that represent this graph. But let's just do it and see what we get. Okay. The first thing when I look at one of these graphs, I want to find the center line. It looks to me like the center line is given there, and I want to take that arrow off. So it looks to me like the center line is about right there, and I think once I draw this in there, you'll agree with me. That's going to be the center line. So that's going to give me my vertical shift right off the bat. The vertical shift is going to be a -1. Okay. Now, the next thing I want to look at is so given that center line, I can easily find anywhere I want, I can find the distance from there to there, and that's going to give me my amplitude. And so my amplitude is going to be what? That looks like that's a distance of 2. So that's going to apply an amplitude of 2. Okay, and now what else do I need to know? Let's look at the period. So let's look at this function from, let's say, from here, and it looks like it completes its trip around the unit circle there. So let's start back here at -pi. We'll go around here, and we complete our trip around the unit circle there. So a -pi to a -pi/3, -pi/3, 2 pi/3. So what's that going to be? My period is going to be, so from pi/3 to pi, I need 2 pi/3. Right? So I have a period of 2 pi/3. And I believe we can go from there. So I know that my function, I'm going to, since I'm starting right here, I'm going to look at this as a sine function. The sine of 0 is 0, so it's starting right there. So I'm going to have f of t equals, let's say, a times the sine of b times t minus c plus d. From my amplitude up here, I know that a equals 2. This is 2 times the sine of, and b, remember we get our period. Let me go in a different color. That blue's kind of, I can't hardly see it. Let's go in a lighter blue. So we get our period. We always do 2 pi over that b right there with the coefficient of t, but we know that that the period is 2 pi/3. So that's going to give me that b. So 2 pi/3 times b equals 2 pi. Now multiply both sides by 3 over 2 pi, and we get that b equals 3. So that term there is 3, and t minus c. C is going to be, I didn't do that one, so remember the sine normally starts here. So let's back it up to there, back it up to pi. So c is going to be plus pi. And then we're going to have plus our vertical shift. And it's going to be, our vertical shift was -1, so it's going to be -1. Okay? And you should start thinking, well, why did you do that? You could have done something different. We could have done, so now let's say it started here. We could have done the same function, or gotten the same graph with using there. So let's say using that, let's call that g of t. G of t equals, and the amplitude is still 2 times the sine of, and the periods, everything, so the b stays the same, 3 times, and we could have done t plus pi over 3. Okay, and then minus 1. So that's 2 representations of this function. So we have one here, that g of t, then we have one here, the f of t. We could do a cosine function. We could, let's see, let's just start here and go like that. I could think of that as a negative sine. I could, h of t equals a negative sine, and it's going to be negative 2 times the sine of just 3t, because it's not, it's the, if I think of it as starting here, it's not backed up anywhere, so it's still, there's no horizontal shift, so it's still 3t minus 1. Okay, so that's the third representation of this function. Is there anywhere where I can start nicely and get a cosine? So what if I start, let me make some room over here. How much time do I have? I'm looking good. So let's get another representation of this function using the cosine. And let's see, what color can I use here. Let's go in yellow. I haven't used that yet. So let's start here. Okay? And do this. Note that the period's still going to stay the same. So I'm looking at this yellow and thinking of this as a cosine function. Okay? Looking at that piece there and thinking of that as a cosine function. So it has been backed up to here, which is going to be half of pi over 3. If you could still see that, that was negative pi over 3. So it's been backed up to pi over 6. So let's call this, let's call it c of t for a cosine function. C of t equals, the amplitude still the same, so it's an amplitude of 2 times the cosine of, and so my b is still the same because the period's still the same. It takes it the same amount of time to get around the unit circle. It's going to be 3, and it's going to be t plus pi over 6. And I have, and my center line is still down at -1, so it's still minus 1 there. So again, there's a fourth representation of the graph of this function. So as you see, you can get many representations, and as I said earlier, it turns out there's infinitely many. So, but the key is looking at it, finding your amplitude. That's always easy. Finding your period. As long as the graph is marked appropriately, it's always pretty easy to find the period. And then use the fact that we do 2 pi over b equals the period to figure out what that b value is. Okay. And then we want to find the amplitude, find the period, find the phase shift, the horizontal shift. And that's just going to, as you see here, that's just going to depend on where you want to start at. Do you want to start here and do a sine function, or do you want to start there and do a sine function, or do you want to start here and do a cosine function? Or you could have started, we did start there and did a negative sine function. You could have started here and done some type of negative cosine function. There's infinitely many options. Pick the one that looks the easiest. So we got a phase shift, we've got a vertical shift, and that's always going to be just finding that center line, and that will tell you what your vertical shift is. And you don't really need the magic number here. The magic number is more for graphing it. So if you can find those and then put it together and know that they're always going to look like this, or for the cosine, it's going to be c of t equals A cosine of B times T minus C. Well, those C's don't match up, so plus D. Let's say this is big C here. Okay, that's big C. Anyway, look at these things. This video is a little sloppy, but anyway, I hope you can use it and it will help you out in the future.